Hi there. All right, graphing is one of the key things that we learn and use in algebra, so it'll be an important thing that you understand. And typically when we're graphing, when we start off, we're doing it in two variables. So that's what this lesson is on, is graphing when you have an x and a y in your equation. All right, so to start off with, I'm just going to do a sampling of different types of problems that you need to graph in lesson 6.2. And this first one actually doesn't have two variables. It only has one variable. So to graph this, I usually like to get a variable by itself. And so in this case, since I only have a y, I'm going to get the y by itself. So the first thing we're going to do is divide both sides by 4 to get that y all by itself. So the 4's cancel out, and you end up with a y equals 2/4, which would reduce to 1/2. All right, so if you have an equation like this, it's kind of a special one. It only has one variable. And what that is saying is that y is 1/2, always. Doesn't matter what x equals, your y is 1/2. So when you're trying to find 2 points on the line, well, remember that these are just an ordered pair, x comma y. And so what this is saying is you can plug anything you want in for x, but the y has to be 1/2. So maybe I plug 4 in. Well, y is going to have to be 1/2. Maybe I plug a -2 in. Y is still going to have to be 1/2, no matter what. Now you get to pick whatever points you want, but you need to make sure that your y's are 1/2. Now I can't do the actual software on this, but you're supposed to plot a point and you can drag it and that kind of thing. But the gist of it is that you're going to plot these 2 points. So over 4 up 1/2. It could go right there. And then the other one is a -2 up 1/2. So -2 up 1/2. And really, I could use other points, but if I get those 2 points, what I end up with is just a horizontal line. Because the y is always 1/2, I'm always going to be up 1/2. So it just represents a horizontal line at 1/2. Let's try this one. This one only has an x in it. It's kind of the same deal, though. Let's get the x by itself, divide both sides by 3. So x is going to be equal to -2/3. So in this case, what that means is when I'm picking points, x is going to always have to be -2/3. Y can be anything I want, but the x has to be -2/3. So if I go plot those, so that means I'm going to go left 2/3 up 5. So here would be a sample point. And then I could go left 2/3 and up 2. That would be a different point. And then you just have to connect those points. So in this case, if you only have an x and you don't have a y, you're going to always end up with a vertical line because your x values in this case will always be left 2/3. So let's try something that has an x and a y in it, which is what most of your assignment will be. Okay, so I gave you started with this one, and it looks like it's kind of an ugly one with that 7/6 in it. But what I did like about it, what is going to make it easy, is that I have the y sitting here by itself already. So I can pick any number I want to plug in for x, and then figure out what the y would be that would match it. But here's the deal. When I say pick any number, I'm going to make my life easy. Let's pick a number for x that will multiply nicely by this 7/6 that I have here. So basically, if you think of numbers that would divide by 6 nicely, that's what's going to multiply nicely. So I'm going to just start off and I'm going to put in a 6 for x. I think that might be an easy starting point. So then what I'm going to have is I'm going to have y. I'm going to kind of come over here because don't have much room to work. So I have a y equals, and I have 7/6 times, and that's going to multiply by x. Well, my x is 6. I'm going to write that as a 6/1 for right now because since I'm multiplying by the fraction. And then I still have my -10. All right, so what's nice about multiplying these is this x is going to reduce with this x, and so all of that just becomes y equals 7 minus 10. which is a -3. So then I know that when I plug 6 in for x, I get a -3 back for my y. So that would be a possible point to plot. So over 6 down 3 would be right here. All right, let's try again. Let's pick another number that would divide by 6 nicely. Perhaps we could try 12. Well, the problem with 12 is that it wouldn't fit on this graph. It's just a 10 by 10 graph. So 12 is getting kind of big. So what I would probably do instead is I would try putting in a -6. Or, you know what? Here's a better option. How about plugging in a 0? 0 would be easy. So if I do y equals 7, 6, okay, so here's a new problem here. Y equals 7, 6 times 0, and then minus 10. Well, 7, 6 times 0 is just 0 minus 10. Well, that's just going to be a -10. So if I plug 0 in for the x, I'm getting -10 back for my y, and so I could plot that over 0, and then down 10 would be this point right here. Okay, so once you have the 2 points, then you can draw the line that goes between them. So if you have fractions within your equation, or if you end up because you kind of did some rearranging or anything, always pick multiples of your denominator to plug in because they'll multiply nicely and you can get rid of your fractions. All right, here's one. This one is actually a pretty simple one because I don't have the fraction. So doing this one compared to the last one is going to be way simpler. All I'm doing is picking a number to plug in for x. All right, I actually kind of like 0. 0 works pretty nicely usually to plug in. So if I were to plug a 0 in for x, I'd end up with y equals -3 times 0. So that's just 0. Okay, so 0, 0 would be a point. That's easy to plot. Okay, and then let's try it again. Let's plug another number in. I don't know. Let's plug in a 2. So y equals -3 times 2. So that's going to equal -6. So when I plug in a 2 for my x, remember this is always x comma y. So when I plugged a 2 in for the x, I got a -6 back for the y. And so when I plot that point, over 2, down 6, I get a spot right here, and then you just connect those to draw your line. All right, so this one's going to be a little harder. What makes this a little bit harder is that I'm not sitting there with that y all by itself. And that really does make the math part of it easier if you have your variable by itself. So, and it doesn't really matter which variable you get by itself. I usually try to get the y by itself. It'll lead in nicely to what the next lesson does. And so in this example here, I'm going to try to get my y by itself. So my first step would be to add the 3x to both sides. And so I have a -y, leave that negative, that's attached to the y, equals, and you could write 7 plus 3x, or you could write a 3x plus 7. The order that you do that doesn't matter as long as you keep the sign correct on it. It's a positive 3x and it's a positive 7. Now, again, only because I know where we're headed in the next lesson, we typically will put that x term before we'll put the number, so that's why I put my 3x first. Okay, my y is not quite by itself. It has that negative attached to it still, and so to get rid of that negative, you kind of have to think of this as like a -1y, and some of you, I think, still like to write that -1 there. So what I'm going to do to get the y by itself is just divide by -1. But everything has to get divided by -1. So when I do that, then the negatives will go away, and my final answer with that y by itself would be a y equals 3 divided by -1 is -3x, and 7 divided by -1 is a -7. All right, so there's my new equation. By getting the y by itself, it's really easy to plug in points to get ordered pairs. And so you get to pick whatever you want to plug in for x. Again, let's try 0. That's usually easy. So then when I plug 0 in, I get y equals -3 times 0 minus 7. -3 times 0 is 0. And 0 minus 7 is -7. So I'd put a -7 for my y value. Let's try another point. Let's try putting in I don't know, let's throw in a negative just so we practice doing that. Let's say it's a -3. All right, so when I plug in a negative, I'm going to have -3 times, and I chose to put in another -3 for my x, and then minus 7. So when you multiply a -3 times a -3, you get a +9 minus 7. And 9 minus 7 is 2. So there's a couple points. Again, you could use any points you want. You don't have to use the ones I'm choosing. I'm just randomly picking those. Basically, you just want to pick numbers that are going to make your life easy. Once you plot your 2 points, draw your line. Okay, and then I wanted to try one more of these. And again, it's just kind of a weird one, and it's really going to be probably an easier one, but because the way it looks, it makes it kind of odd, because it equals 0. I'm still going to work on getting a variable by itself. And so I'm going to work on getting my y by itself. So I'm going to add the 4x to the other side. So 4y equals a 0 plus 4x, which is just 4x. And then divide by 4. So then the 4's cancel out. So really it just simplifies to a y equals x. Okay, that's a pretty simple little equation. They want me to plot some points. They don't really have a place for me to enter my ordered pairs, but I'm going to go ahead and do it just to be consistent with the last problem. You get to plug whatever you want in for x. Let's plug in 0. But since y is equal to x, if x is 0, so is y. Let's put in a 5. If x is 5, y is equal to that. So 5, 5. I could sit there and do that all day long, but let's just plot those 2 points, 0, 0, and 5, 5, and draw your line. So don't let that 0 freak you out. It actually kind of is easier. Okay, let's move on to something different. Let's talk about x-intercepts and y-intercepts. An x-intercept is where your line touches your x-axis. So in this example, my x-intercept would be a -4. The y-intercept is where it crosses the y-axis. So in this example, my y-intercept is a 4. To find your x and y intercepts, since they always fall on the axes, if you think about the ordered pair for this x-intercept, it's always going to be up 0. That point would have a y value of a 0. And that would be the case for every x-intercept. So your x-intercept, you're always going to plug 0 in for y. To find your y-intercept, it's the other way around. Your y-intercept is right here, and since you're not left or right when you're plotting that point, then that makes your x value be 0. And that's how you find your intercepts. Okay, so let's look at this first one. If I want to find the x-intercept, I'm going to make my y be 0. So for the x-intercept, I would have, let's come over here, x-intercept. So I'd still have the 2x, but I'm going to make the y be 0. And then you just got to go figure out what x equals. So that becomes 2x plus 2 times 0 is just 0, so that goes away. Divide by 2. So x is 4. So my x-intercept is going to be a 4. So that means it's going to cross my x-axis at 4. So when I look at my options, because this is just multiple choice, this one well, this one here crosses the x-axis at 4. So this is a potential answer. On this one, the x-intercept is -4, so that is not what I'd be looking for. Over here, again, it crosses at a +4, so it could be C. On the last one, it crosses at a -4, so it can't be that one. So I know that I'm not going to be using B or C, or B or D for my final answer. So now we have to look at what the y-intercept is so we can determine if it's A or C. To do your y-intercept, you're going to make your x be 0. So you're going to have 2 times 0 plus 2y equals 8. And 2 times 0 is just 0, so that will go away. And I have 2y equals 8. Divide both sides by 2. And my y-intercept is going to be a +4. So when I look at the two that are left, this is the one here that has a y-intercept of +4. So then I know that my answer is going to be C, and that's what I would put in the box. All right, so let's work a little bit on these x and y intercepts. These actually came out very nice. Your x and y intercepts don't always do that. Let's try some that may or may not come out nice. All right, so the y-intercept. So looking at this one, the first thing they want me to find is the y-intercept. So I'm going to make my x be 0. And so when I go up here to this equation, if I make my x be 0, so this time I'm doing my y-intercept first. I made my x 0, so I'm going to have a -6 times 0 minus 9y equals -54. So this goes away, and I have -9y equals -54. When you divide by the negative, it's going to make that go back positive, so my y-intercept is actually a +6. All right, let's try again. We have to find our x-intercept. So to do the x-intercept, I'm going to plug 0 in for y. So my equation goes -6x minus 9 times 0 equals -54. And again, anytime I multiply by the 0, that's going to just end up going away. I have a -6x equals -54. Divide by your -6, and x is going to end up equaling a +9. So for my x-intercept, I plugged 0 in for the y, and I got a 9 for the x-intercept. To plot it, you know that they're going to end up on the axes. So for my y-intercept, I'm over 0 and up 6. And for my x-intercept, I'm over 9 and up 0. And then that's my equation. So this is kind of a nice quick way. Now I went through and showed all the algebra on that, but what I really do sometimes is I kind of do that in my head. Now I'm not always that lucky, but because 6 and 9 both go into 54, that's why these came out nice. And what I would sometimes just do, if I'm looking for my y-intercept, I'm going to plug 0 in for x, and I kind of just put my finger over this whole term and say, all right, that's going to go away because it's going to be a 0. And then I would just divide both sides by -9 to see what the y equals. And then when I'm looking for my x-intercept, I'm plugging 0 in for y, so I'd put my finger over this and say, all right, so -6x equals -54. Divide both sides by -6, and I'd have my x-intercept. So if you want to do some mental math on that, you are welcome to do that, especially on these ones that have these two factors that go into this number. It's a nice time saver. All right, it's not always going to work out like that, so here's one more of these where maybe the x and y-intercepts aren't that pretty. And I know that this one's not going to be pretty because 9 and 5 aren't factors of 11, so I know when I divide those out, it's not going to be pretty. All right, so here we go. I'm going to try to do this one a little bit of a shortcut to try to help you along time-wise. So I'm going to start off and I'm going to look for my y-intercept. Since I'm looking for the y-intercept, I'm going to plug 0 in for x. So I know this whole term is going to be gone. And so when I find the y, I'm just going to end up dividing both sides by 5. So my y-intercept, if I plugged 0 in for x, I got 11/5 back for the y. Let's try again. This time I'm looking for my x-intercept, and so I'm going to plug 0 in for y, which is going to make this whole term disappear. And so all I'll do is divide both sides by -9. And so if I plug a 0 in for the y, I end up with a -11/9 for my x-intercept. So then I go back to my graph and I have to plot these. They're not very pretty to plot for sure. 11/5, you could change that to a mixed fraction if that helps you, or change it to a decimal. It ends up being 2 1/5. So I'm kind of eyeballing that over 0 up 2 1/5, somewhere like right there-ish. On my x-intercept, -11/9 is the same as a -1 2/9. So for my x-intercept, I'm going to go left 1 and a little bit and up 0. So it's about right there, and I can draw my line then. All right, so graphing with two variables, very common thing that we're going to be doing in algebra. Good luck. Hope this tutorial helps.